Yeah, hi all. I'd like to welcome you to my talk called Docke Introduction and Overview. So don't be scared. It's not getting that complicated for right after lunch. I'll leave the command tool to the other guys. So let's start by introducing myself. My name is Holger Gantikow. I once studied computer science at Furtwangen University, graduated back in 2009, and I'm now working as a senior systems engineer for an IT service company. And there I work for a team providing IT services for customers, computer-aided engineering site for German automotive engineers, which includes operating their heterogeneous environment and on-site HPC installation with roughly 500 plus nodes, at least at this part of the customer. And it is used for various CAE-related applications. So also I'm a frequent attendant and speaker at IT and especially Linux and open source conferences like CeBIT and Linux Talk, and I recently took a PhD program where I'm doing research on improving HPC in cloud-related environments. So if anybody should be interested in service level management as a service, accountability for clouds, you should check out the homepage of Hochschule Furtwangen. It's called Wolke HS Furtwangen. They're doing research there on these topics, and my work goes there too somehow. So the company I work for is Science+computing AG in Tübingen, and our main focus is IT services and software for technical, computation, and scientific environments. So more or less everything that has to do with complex distributed environments, like operating these environments, IT administration tools, queuing system, everything that goes into compute clusters, data management, visualization, virtualization, IT security. And we were founded in 1989, have offices in Tübingen, Munich, Berlin, Düsseldorf, and Ingolstadt, and are around 320 employees, and now belong to the Athos Group. So I think I'm gonna skip this. If anybody should be interested in new job opportunities, we've got several offerings, so feel free to check out the job site. And enough of commercial break, let's get to the topic. So the title is Docke Introduction. So I'm going to start with, an introduction to Docke, obviously, what it is, what it's not. So don't worry, it's not going to get too technical. Remember lunch break. And then I'm going to continue with why HPC matters with focus on scientific computing community. And as everybody probably has heard, Docke is way too insecure. I'm going to cover this with a little bit of security as well. If there should be time left, I'll give you a very brief introduction on how to get started, but we'll see if there's time left. So let's do things differently this part. So a few questions to the audience. Please raise your hand. Who of you has heard of Docke? Okay, so you're exactly in the right room. So who knows what Docke is and how it can hopefully make your life better, at least your IT life? Okay, most of them. Who has actually tried Docke? Okay, and who uses Docke? I don't know, on a regular basis or something. Okay, and who is using Docke in production yet? Okay, very few people. And do you use additional tools? Okay, so nobody's really using bare metal Docke, really. Okay, so tools are not included, but for the next time perhaps. So what it is, what is Docke? So Docke is the sort of hype topic at the moment for quite a while actually now, and there's really no conference you can attend without finding talks on it. So first of all, it revived the already dead considered operating level virtualization, but more on this later. It has gotten much attention, praised by excited users, lots of creative ideas on how to use it, but also rants. And at the moment, everybody seems to want to join the Docke fan club, and even VMware and especially Citrix, who are about to do something with Docke with the next Xen server release. Last time I spoke with them, they were not exactly sure what they're going to do, but they wanted to do Docke. So Docke seems just like the sort of must-have feature at the moment, which is justified, I think. So, if you look at the definition from the Docke website, it used to describe Docke as an open platform to build, ship, and run distributed applications anywhere. They later redefined the anywhere aspect to laptops, data centers, especially VMs, or the cloud, and which shows that it just goes further than providing some sort of runtime for containers, but also providing a complete environment around it and more or less an ecosystem. And that it's meant for both developers and admins and yeah, quite on a lot of systems, which looks like a very big promise. So what are we here for? Docke. And let's start with a quick Docke 101. So first of all, Docke is an application for isolating applications, and as technical means, it uses operating system level virtualization. And it simplifies just the transport, the provisioning, transport, and isolation of used resources. The isolation means that container A is not meant to have any access to what's running inside of container B unless otherwise wanted. So it uses the kernel technology, C groups, and namespaces, and it formerly relied on the LXC, the Linux kernel Linux container interface, but moved to their own libdocker more or less recently. And it offers quite a lot of features. So let's start with some terminology. We're going to use this for the talks, or I need this for the talks later. So if you look at the diagram, you can see a lot of things. First of all, you have your Docker host. This is the system that is actually running the Docker daemon, and when comparing to regular virtualization, this is your host system. And then you have the Docker daemon, which controls the containers, and it is accessed by the Docker client. And in general, a command line interface for interacting with the daemon. So those are the, I should have shown this. Those are the core components. That's the way it looks on a Linux system. When you want to use Docker on Windows or OS X or something, you can't use it there natively. So the reason behind this is, it's not supported, at least for OS X yet. Microsoft is working on it. And you have to have some special virtual machine with the host system in the background. This is why we have this additional layer here. So for the workflow components, most important here are the Docker images. These are the entities containing the application you want to ship and all the required environmental components like libraries, for example. So the Docker container is a running instance created from one of these images. And it's the entity you start or stop, for example. Then you have the Docker registry, which is more or less some sort of app stores for Docker images. You can have these public, by example, accessing Docker Hub, or private registries as well. Then I think he's going to cover later are the Docker files. Those are the definitions required to automate an image build. So I'll hopefully give you a brief overview on the getting started section. So what can Docker do for you? Save lives, perhaps. In general, people now talk about how great Docker is for shipping code and makes it just less error prone, how it can end fights between developers, writing applications and shipping them to operations for deploying them, and afterwards it doesn't work. And everybody says, but it worked on my machine. Yeah, but it's not. So where I come from, things are quite a bit different. I don't have to deal with developers, God bless, I have to deal with customers. But at the end of the day, we all need we have a good need for isolation dependencies, and the results are more or less the same. So what's the problem? So this is a classic setup without Docker. I have a web server. It's just a fictive example. I have a solver, and they share this libc. If I don't know, for any reasons, I have to update the web server. It might require a new libc version, which might break the solver, for example. So risks can arise when either the application or the operating system is either updated or well outdated. So for example, new applications might not, I
mean, maybe Solver, is everyone familiar with Solver? It's just, could be any program, right? So,
probably. It was more or less from an HPC background, so it's, this could be any generic applications. We run into this on a more or less daily basis. So the main problem is, for example, new applications might not run on your outdated or conservative operating system, or outdated applications might not run on a current OS. For example, we had to keep a historic SUSE 64 installation for years because it was the newest version for special required code that was able to run only on this machine. And this code was necessary for customer having the possibility to do some recalculations of stuff. So this code was just legacy, but he insisted to keep this machine alive. So besides legacy requirements, even in everyday use, there's also certain risk for breaking applications when updating the operating system, even with enterprise distributions. And this is just bad for critical applications. For example, when updating, you have to install security updates. Happened recently, and it just broke one of the CAE applications of one engineer. The guy was sitting around and said, "Why the heck did you update my machine?" And security policy. It's not our idea. We have to. And it was just work. He was just sitting there and couldn't work because it broke his machine. So we had to reinstall the machine back to the old level. Skip the security updates for his machine and getting running again. So, and sometimes also it happens that trying a new tool, for example, out of curiosity, can result in the need for updating an operating system. Docke changes this. Don't get confused by these. They're just in case I give a handout and summarize what I said. So in a containerized setup, we have this. We have container A, container 1 containing the web server, and container B 2 containing solver A. So with Docke, what we have here is all in one entity. So both applications and all their required dependencies are isolated. So updating libc in container has absolutely no impact whatsoever on libc here. So, and we have a portable entity. All you need to run a container is the Docker runtime here. So this means you can move this container to whatever machine you want, your laptop, your workstation, your cluster, even your cloud or your bare metal HPC provider or something. So one not so typical example with this legacy hell. Don't get scared. Actually, it's quite simple, and I choose this picture because it contains all the fancy buzzwords we learned, like Dockerfile, and so on. The point is, we had to containerize a historic FlexLM license server. So, and it's just an example for legacy dependency from hell. So don't get scared by the complexity. It's just, in fact, it's really simple. A colleague of mine was tasked with this. A customer had to use a special outdated license for MATLAB, which would only run on a very specific vendor daemon, which is required for the license to run. And this, on the other hand, would only run with a very specific FlexLM version. So both would not run either on a current CentOS system, only with a very outdated version you didn't want to keep around due to security issues. So the solution was to containerize the vendor daemon along with the outdated FlexLM in a CentOS 5 container, which is not really supported, but it worked. And yeah, as this was a license server triple, he had to use 3 containers, you can see here. And they were network accessible by the client. And so, yeah, we got this thing working. Redundancy was not required, so he could pack it all on one host system. So, but the essence of it, you can, for example, use Docker to solve such problems. So another nice feature, I guess I should skip due to time reasons, is the possibility to have layered file systems and layered images. One example containing your base image, all the HPC images share, and with different application layers on top. So virtualization 2.0. So yeah, is Docker some new logical way to do virtualization? Some people tend to see Docker this way. First of all the things mentioned before can be done with VMs too. But let's look at the architecture. Is really everything harder, better, faster, and stronger? So this is the typical way virtualization is done, and the most frequent way, I'd say. We have our hypervisor layer. This is type 1 hypervisor, which sits directly on the hardware, and it offers a narrow interface for the virtual hardware upwards. And one of the major advantages in this approach is the possibility to mix the operating system. So running, you can have a VM running Windows and one with Linux on the same host system, as no operating system resources are shared. So container-based virtualization works quite a bit different. It offers no real hypervisor and virtualized hardware layer, which means a much smaller stack. The concept itself is not new. For example, Linux containers, LXC, used this approach since 2008, but never really became widely accepted. Change root for isolation is too old and lacks many features, and some might even remember Solaris zones or similar techniques from more or less any Linux operating system. So the advantages of operating level virtualization in general is a better performance, more on that later, and due to much smaller stack when you compare it, resulting in less overhead, faster startup times, but it limits the container operating system to the host operating system. As the running kernel is the only real resource shared and the only component that cannot be changed. But don't get confused, you can have an Ubuntu running on a CentOS host or something, but you just can't run a Windows inside of the container. So for HPC, this is not really a disadvantage, as nearly 100% of all HPC installations are Linux-based. You might even get a big advantage here, as you have only one kernel running. Think of patch management, for example. When you only have one kernel running and you can use technologies like ksplice for rebootless kernel updates, this is just great. So what if I told you Docker containers are no magical virtual machines? There's something different in my opinion. So what's different? Compared to VM, Docker separates applications from the underlying operating system, the way VMs separated the operating system from the underlying hardware. But when you want to ship an application, the OS is somehow part of this requirement. When you think of an appliance or something you want to ship to a customer, so you have a pretty large requirement. So using Docker turns this fat requirement for VMs in a rather lightweight one. And when you compare it to other operating level virtualization techniques, Docker is more or less bringing containers to the masses. So by giving them just the tools and workflows around container, and that's making it easy for everyone to use and the whole ecosystem that goes with it. For example, think of Docker Hub, which is often compared to GitHub for Docker images, where you can go on and take one image, base your work on it, and create something completely new, completely different. The way you can fork programs, projects, for example, on GitHub, and share this too afterwards. I think this is a great opportunity here. So the main reason I guess is this. I remember when I spoke to Wolfgang at CeBIT about Docker and how it somehow became a game changer for operating system level virtualization, and what makes it somehow superior to LXC, and everybody is crazy about Docker. And he just said, well, we tried that, it was just too complicated. So I guess this is more or less the main reason why Docker is they're popular. It's just usable compared to other solutions. So, in my opinion, why does Docker matter, especially for computing? As this is an IC event, I don't think I have to go into high-performance computing, that it goes by many names, that we used to do it on proprietary systems, now running on clusters for a decade, I guess. And some are even doing this on clouds nowadays, while others are still stuck with the workstation neatly tucked away under the desk. So it's all about somehow, solving computational problems by many applications. For example, oil and gas, big data, or the customers I work with do computational fluid dynamics. And they all share certain requirements besides the need for powerful systems. So HPC, we all get issues, and I think the point where Docker can be of great help is, first of all, this, having a clean slate for applications. As mentioned before, Docker does a pretty good job when it comes to isolating different applications. This is important when you have different versions, have needs for different conflicting libraries. And this cannot be scripted anymore, or is somehow a pain in the ass to debug. Or when running legacy code on a new operating system. Or when you have to run new code on legacy operating systems, or for packaging complex software. And providing different versions of them alongside. For example, when you use OpenFOAM. So then going a bit further, one can see Docker even as an alternative to classic application rollout. So you use Docker pull instead of yum install or whatever one uses for rollouts. So the performance overhead is that small that one considers this as a viable alternative to a classic rollout. Think of installing a new cluster. You have your classic mode installation, you install the operating system, You install the applications and configure the application and so on and so on. So why not just roll out the operating system and the Docker runtime with it, then use pre-configured images for this. This also makes repurposing a cluster more or less attractive, perhaps even for bare metal HPC providers. So when you look at the deployment, it's more or less this way. Docker is almost as portable and flexible as VMs, but it induces much less overhead than VMs do. Another aspect I think is pretty attractive in computing environments is to homogenize heterogeneous clusters. I know it's a bit hard to read, but the idea is simple. Clusters are usually pretty expensive and meant to be utilized to the max. But at least where I come from, clusters are often bought for one team and running one application or one category of applications. So making the resources interchangeable, for example, when one team has an empty queue while the other has not, is often quite tasking because parallel installation of different software can be a problem, and reinstalling the cluster for such a short time does not make any sense speaking economically. So Docker offers here the possibility to use a suitable job image at startup time. What we need, and I forgot your name, sorry, is going to talk a bit about a bit later, is the way of how to integrate this into a queuing system. For example, LSF is already got something working, but I think it's not that feature-rich as one would like it to have. So another great thing for scientific computing is when you have the possibility to pass on an environment. So Docker is a tool that enables this. For example, passing on an entire workflow and not just one application to a third party. It can be nice, for example, testing somebody or the old problem when debugging any problems with an ISV. And he says, yeah, okay, those operating systems should be certified. What did you do different than the way we did? So why not just ship it directly in a containerized form? And the access to additional resources is getting much easier. For example, dumping your image, your container on a cluster or to a cloud, for example. And deploying software this way might also be considerable for bare metal HPC providers because dynamic short-term use of resources might be a problem here in case an application is not already available there. So why not give the customer the possibility to bring along his container running bare metal? Well, why not use classical virtualization? I already talked about a bit on this, but I think besides the workflow aspects I already mentioned, I think the important aspect is performance. Performance is superior in just many use cases. Docker offers almost bare metal performance. VMs have gotten better much over time, I know, but this is already true for the startup time. So think of the time a VM that perhaps just does one thing, one job for computation or something, takes about a minute to start up. This might not be a problem if you've got a compute job which would be running, I don't know, 3 days or something. But for quick computations, this can already be a problem or at least annoying. So I brought along some benchmarks. The first one is an IBM research paper which measured Docker performance in many circumstances against KVM and bare metal. And the other one is an internal study which did at least a quick test with a CAE application. So if you haven't read this paper yet, you should definitely read it. It was published last year, and it benchmarks Docker over the course of about 15 pages. And what they did is the bare metal setup versus KVM versus Docker, all three on IBM systems, and it was a really wide test with different storage and network configs. They used Limpack, some might be familiar with. Memory, they benchmarked the memory throughput, the memory access time, network bandwidth, and so on, network latency, block I/O. They used Redis and MySQL as a database. So I don't think it's not worth discussing all the outcomes. What's really important is the summary that in general the performance of Docker versus KVM, it equals or is usually better in all categories than KVM is. KVM in general means at least to a certain degree, loss of performance. And even though it has gotten much better on current systems. When you compare Docker performance to bare metal, there's very, very little overhead, even though one should be taking aspects like using NAT or choosing the right storage backend into consideration. So if 100% bare metal performance is required, you should take the pros and cons into consideration. What might be interesting or important for computing is when it comes to optimal latency and high I/O throughput, Docker seems to be the better choice with the findings. If only CPU and memory performance is the thing mattering, you can also pick KVM, but you don't have any loss when you pick Docker. The interesting thing is their forecast, because virtualization performance has gotten much better over time. They expect this to get even more better. But on the other hand, they expect the opposite to happen with Docker, as performance is already that close to bare metal, and any additional layer might degrade performance. So to sum this up, you should read this paper, it's worse. Our own research was published at a scientific conference called Closer this year, and it did much less benchmarking. We just only concentrated on the performance degradation when comparing Docker performance to bare metal for real CAE applications and the conceptual aspects relevant for HPC as well. Thanks again to Sebastian Klingberg for doing the benchmarks. And our test environment consisted of several AMD servers, all running CentOS. We used Abacus and an application, a demo job that came along with the installation, and we considered both local storage and a Elasto file system as a storage backend, and further details I'm going to skip. What's interesting are the results. So the average runtime native versus Docker, and our benchmark more or less showed that Docker only adds 2% of overhead when using local disk as a storage backend, and 1% when using Elasto. So for the overall runtime of this job, of this exact job, this just meant 1 respectively 2 seconds overhead. So because it was a really short overhead, but a short job. But think of this, putting this in a VM, waiting for the VM to fire up. It would have been almost the same time like the job actually runs. So especially for short running jobs, using Docker might be of great use. So what's next? A little bit of security. HPC often means dealing with confidential data, and this problem even gets worse in multi-tenant environment. For example, when you have to deal with research data or something, and as everybody has heard, Docker is way too unsecure. I think we should take a quick look at this if this is really that much of a problem. So first of all, opinions matter. Let's get started with some quotes that were taken from a very good talk with the misleading title, Surviving the Zombie Apocalypse, which Ian Jackson gave at this year's FOSDEM. So what he brought along was this quote from Jack Welch that some people just make the mistake of thinking as containers as a just better and faster way to do virtualization. And from a security point of view, containers are much weaker, at least to a certain degree. In my opinion, virtualization doing containers is a bit different than doing the way using virtual machines. But even though the internal concepts like C groups and namespaces, the concept Docker relies on, which have to be considered secure, VMs rely on a much more tight interface offered by the hypervisor. I already talked about this, and it provides less working surface for attacks than the rather broad Linux kernel interface. And Ian Jackson compared this to a house of where you hide from the zombies. Would you rather pick the one with huge windows or the one with really tiny holes? If your life depends on it. Another quote from Jerome, some might be familiar with him. He's working for Docke. And virtual machines might not be that secure today, but they're catching up, and Docker is headed, at least they say this, towards security. But he's not denying that VMs might still be considered more secure. And then a nice one from Theodor Rath, who has some certain very distinct views. First of all, his quote is not directed against against container-based virtualization. It's straightly headed against virtualization at all. And he says that, yeah, you're deluded if you think that virtualization can be secure if the people writing it don't know how to write a secure operating system. For fun fact, OpenBSD started an own virtualization layer recently, like 2 weeks ago or something. So we'll see if they can deliver something better than we used to use at the moment. So, but where he's absolutely right is the point is that there is no such thing like free lunch or complete bug-free software. The same goes for virtualization layer as for any software out there. So the question is how to deal with it and how big is the impact and does it really matter that much? So counting some numbers. Ian Jackson and his colleague George Damler did quite a bit of bean counting, and they counted all the vulnerabilities, parallel virtualized Xen, KVM with QEMU, and Linux containers, and classified them into 3 categories. Privilege escalation from guest to host, so where you can get higher privileges. Denial of service by the guest of the host, so your host goes down or something, for example. And information leakage from the host to guest, so which means you can get as an attacker additional information on the host. And one should mention both are working for Citrix. Citrix is a company behind Xen at the moment, but the findings were that parallelized Xen offers the smallest potential for attacks and a higher risk and a much higher risk for containers if you use them in a way as a general container, the way you'd use a VM for example. So the point is, when you use containers as application containers, where the user has no access as root or something, all the vulnerabilities go down to about the same level as KVM, which is considered more or less secure. So if you have the possibility to not use containers as a one-to-one replacement for virtual machines, it's pretty okay to use them. So I think, in my opinion, when skipping all the possible bugs and CVEs, it shows that, in general, the most level of frustration and problems arises from users or certain misunderstandings. And moving a bit away in the opposite direction to the desktop, people just do wonderful things with Docke, but sometimes just overshoot the target. So this is a pretty good example by the lovely Jess Roselle, who just gives real fun talks on Dockers. And she promotes Docker as a sandbox for desktop applications. Her ideas are interesting without question, but an actual sandbox with really strict isolation is somehow different. First of all, she shows how to run MUD and similar applications inside a container and realizes that data like configuration has to be passed into the container. For example, Skype requires access to audio and webcam or something. She has many examples, including Docker files and Docker run commands. So if you want to learn something about using Docker on the desktop, check this out. But don't do something like this. She says she was really mind-blown when she found out that she could partition her local hard disk by passing the appropriate device into the container. You see it's dev SDA, which means it's a local hard disk. And she passes this into her container and then can run gparted. So partition her hard disk inside the container. The possibility is nice and probably legit for some use cases, but I was mind blown of the idea to do so. So don't do everything you just can do. The point is, the article started quite a bit of discussion. Most of them disadvised that she should use containers for desktop applications with access to the X server, and it might open a risk for keyloggers or something. Another nice thing is, there it is, it's a bad idea to do something like this. Wait, I get it a bit bigger. If you have access to the Docker command line, you can do such a fun thing. You start a container, it's a Ubuntu machine, you pass on the / which means the root file system of your host system. You mount it or pass it in as TMP and inside the container, and then you just do a recursive remove inside the container, and the file systems of your host system are actually gone. Think about what you're doing, as with all technology. The problem is that without user, that at the moment, it's enough to be a member of the Docker group, that the group on your system that defines who is allowed access to use the Docker command line interface to start such a destructive container. So Docker containers are currently started under the UID of root, which results in rather, I'd say, extensive permissions. That means passing in the right path or device or something can let you do fun things, but also pretty destructive fun, and you otherwise wouldn't be allowed to. So if you go on a bit further and think of this in an NFS environment, where the Docker host is doing that and has access to interesting shares, and the curious user has the right to add users inside the container, and he can just do fun things and, yeah, still his curiosity. So, yeah.
So that's quite interesting, because that prevents us from putting Docker in production.
Mm-hmm.
So it's definitely would be going as development, because such situation with users won't be possible. We cannot allow that in a big system.
Yeah.
Where it could be very destructive.
But NFS version 4 could help to a certain extent.
Now that I even talk about local,
Mm-hmm.
local for any device. I mean, when the user is allowed have root access, that's a problem, and then it cannot be in production.
Mm-hmm.
So what's the plan for, I know there are some workarounds going on, like my Docker and other stuff will be coming out.
I'm going to talk about this exactly now.
Okay.
So I didn't want to freak you out by any means. I think the most issues can be dealt with by some sort of organizational means. This might mean when things get a bit more secure, they get a little bit less easy and a little bit less fun, but yeah, that's a general problem with security. I just want to share some ideas on how to deal with these issues. He's going to talk a bit more about some of the stuff later, and he's working on this. Something I'd be really, really wishing for is a fine-grained access to the Docker command line. So as I already mentioned, it's enough to be a member of the Docker group, to have some fun. Yeah, if no other security measures are in place, we'd all wish for a more fine-grained access model to the Docker client. For example, limiting access when passing directories into the container or something. This is something he's talking about a bit later. Yeah?
But I mean, batteries are included, but removable, right? So you can pass all the Docker commands through a proxy kind of program which filters out and defines, okay, this user is not.
You can, but it's not the way it's done by default.
Yeah, sure, but I mean there are ways to secure it, but
yeah,
it's
that's what I'm talking about.
Yeah, just
furthermore, we expect some improvements for SE Linux, from SE Linux. The point is, we just wish to have something like this out of the box and being more secure by default. You can do a lot of great things and solving lots of problems, but yeah, they just take effort and just makes things harder. From a complete paperwork level of things at our company, joining the Docker group means that you have to fill out the exact form for use to getting root access to your own machine. So also on the wish list is the possibility to start containers with lower permissions as implemented with LXC, I think. One of the possible solutions besides the proxies he's going to talk about later is to use some form of more or less ugly wrapper scripts. For example, by limiting actions that might result in bad things by something like sudo scripts with hard-coded calls to the Docker command line, or stripping stuff away. On a more self-service oriented level, some sort of self-service portals with limited access to well-defined containers or path option can help, I think. This is in general considered to be wise in a multi-tenant environment with a higher level of untrusted users, an increased chance of attacks or something. Okay, so use something around the straight access to the Docker command line. As I already mentioned with hints to the Ian Jackson talk, is use of application containers instead of system containers wherever possible. So yeah, further risks can be reduced by the already discussed application containers, by providing containers for special use cases, for example, compute jobs. In my opinion, there's just no real reason a user should be granted something like a root shell for computation. This is something you wouldn't do with containers, you wouldn't do with VMs, you wouldn't do with bare metal systems. So a containerized compute job is, in my opinion, the perfect example for an application container. It just does one thing, and that is, yeah, turn input data into output data and then cease to exist. So the main problem is when containers are considered as sort of one-to-one replacement for VMs and the user is granted interactive access to. This just increases risks of all things, as with all systems. So rule of thumb, one process per container. When you want to move Docker to production, a good thing you can do is use your own registry instead of Docker Hub or something. This completely eliminates the question, can I trust this image? Is this image provider secure or whatsoever? When you use your own registry. The another thing is for at least for HPC, you can find tons of images there, but for HPC it's rather narrow what you can find there. And the same goes for Docker files. As goes for any code snippet from the internet. Read them, understand them, and only use if you understand what they're doing. So as I've got some minutes left, I'll just give you a brief overview to get you started with Docker. I'm just going to walk you through a few installation steps. Yeah?
Maybe if there are questions, maybe we halt here before you turn into the getting started.
No problem.
So any questions so far?
Okay, I'm just gonna give you a very brief introduction, show you how to start your first container, what you have to keep in mind on Windows and Mac OS. So the idea is you can just go out, install Docker if you haven't done before, and start with a simple Docker file or something. So installation is pretty simple. On Linux, it's just a matter of apt-get install Docker, yum install Docker, or use the script provided from the Docker homepage. Windows, it's more or less the same as for macOS. You've got a fancy graphical installer, which is the Docker toolbox. The formerly used boot to Docker is now deprecated, and the Docker toolbox is the way to go. You use the installer. It says what's included. For example, the Docker client binary, Kindmatic, which is a fancy desktop GUI for Docker. I never really used. And some other stuff, we just can skip. After the installation, you can pick the tool you want to use. I think if you want to try some tutorials, I'd prefer if you use the command line interface, because clicking in a GUI is not that nice. So when you click on when you start the GUI, the command line, after an eternity of 30 to 60 seconds, which are required to start the VM, as Docker does not run natively on Mac or Windows or something, you should be presented with this, moby-doc, and the hooray command line prompt. So remember that Docker does not run native, and you need this special Linux VM, and it's included in the installer. So I quickly checked what OS I'm in, then first an initial Docker run. I want an Ubuntu, and I want to have access to Bin Bash. And when pulling an image for the first time from the registry, this might take some time. And hooray, I got down there and a terminal inside a Linux container. And remember, you have to pass a command, something like sleep 30 instead of Bin Bash will also work, but it results in a container living for roughly 30 seconds. So as I mostly use CentOS, I did the same with the CentOS operating system. There you go, I have a Red Hat release or CentOS release. That's the way Kindmatic looks, the graphical interface. It has a bit of an App Store look and feel, including likes, which is quite fancy, haha. But it works too. And I guess for most tutorials, you should consider using the command line interface. To show you that there's actually a VM running, I just grabbed for the VirtualBox processors, and it shows here that there's a headless virtual machine running on my system. For the benchmark, I talked about startup time. So what I did was just use, stop the time for Docker run of a Hello World container, which just echoes hello world out, and you see it is started, did his job, and terminates after like half a second. So using this is really fast. Imagine a virtual machine, even with stripped down services and something, and doing this would be roughly, I guess, in 30 seconds area. So that we've talked about Docke files and conclude this very little demonstration of how to get started with the basics. We're going to create a very small Docke file, and it just consists of this. It starts from an existing image. It's the Ubuntu image. I did not include any specific version or something. This is just really meant to be pretty basic. And you can also see that images can depend on one another. Then I'm going to run the command apt-get install -y engines, which is needed for the web server to be installed. And afterwards, we're going to run a command that starts the web server in the foreground. And we're going to expose port 80 HTTP so that we can access the web server from out of the container. So afterwards, we have to build the image and wait for a moment until it's ready to use. This is the build command. Docker build, my fancy label here, and the folder where it finds the Docker file. So there you go. This is what happens when the image gets built. In case you're wondering what the using cache means here, Docker will cache the results of the first build of a Docker file, so allowing subsequent builds to be faster than starting from scratch. And it was pretty fast in the end because I had to fiddle a bit with the engines command to keep it running in the foreground. It's really nice. So now what? We want to access this, and we can and we use Docker PS to find out the ID of the container. This is required for terminating it afterwards. And Docker PS also shows what port on the host it is running. It's 32773, and it's mapped to port 80 inside the container. And this is all we need to access it. Okay. What you should remember is, at least in macOS, you're not able to use localhost. There's no mapping from a port on your system inside the VM into the container. You have to keep this in mind. It might get you confused if you, at least if you're used to working on a Linux system and switching there. So what you have to do, the output from the command line interface shows that the Docker host system is running on this IP address, and when you do this, ta-da, there's your web server running. And you can also, if you don't want this random port, you can specify the port he has to use using the -p flag, which specifies the host port. And to the conclusion. So first of all, Docker has a lot of things to offer, especially for computing and scientific workflows, in my opinion. It's easy, first of all, easy deployment of application and its dependencies, configuration isolation that goes along with it, and this at almost no performance cost. Performing close to bare metal. Or the possibility to use the same image on all the machine you want, your laptop, your workstation, cluster, cloud, whatever. And easily share it with other third parties. For HPC, the possibility of Docker can lead to increased dynamic utilization of resources, even for legacy applications. Most of the aspects are also doable with VMs, but Docker has a complete set of tools around it, and it's just much more fun to use. And speaking of tools, we haven't spoken a single word on orchestration tools, but this is not the topic of this talk. On the downside, it can lead to a higher organizational cost if done in a more or less secure way, at least at the moment. And for the German speakers, this image might be funny. I'll explain to the rest over coffee. What I want to talk about is, even though Docker already has very, very lots to offer for computing, we still hope for ISV support. The software developers directly containerizing their applications, better support in queuing systems later at this talk, and ways to easily implement Docker into current HPC workflows. This is something we are taking a closer look at the moment. So overall conclusion, Docker is not fancy new virtualization 2.0. It's something rather different. It's pretty good for portable deployment. It's for sharing your application and the reuse of components. It performs better for computing than classical virtualization. Security, as with everything, has to be ensured, but can be ensured. And getting started is quite easy. So go out and enjoy. And thanks a lot for your attention.